In the document that we linked, there's a couple different things. One, it's really handy to follow along. If you fall behind, you've got text for everything in here. If we don't get through the entirety of the tutorial, because it is a lot, you've got it and you can actually kind of finish it up on your own afterwards. So make sure that you kind of save a copy for yourself, and it'll be here. So you should have gotten it emailed to you from Games for Change, but you should also have access to this here as well. And then if you haven't already gotten Unity booted up, you definitely want to start doing that now, because it can take a couple minutes to get loaded in. So we'll kind of stall a little bit here at first, just to make sure everybody has some time to get loaded in. But definitely kick it on. And then again, at the top of that document, there is a link to the asset pack that we will be using. There's also a link to the survey. So we know that some people participated in the class that we ran last week. We really love feedback. It allows Danielle and I, after the fact, we will sit and talk and debrief how any of our trainings go, and your feedback helps us fine tune for different classes that we teach in the future. So if you attended like the intro to teaching with Unity, we take all the feedback that you guys give us and we make sure that we make edits to things that need to be edited. Same thing for this one. This is the second time that we've run this particular session. The session's really different because it's hands-on and you're working in Unity the entire time. So we would really love feedback. The first time was just sort of like the crash test. We've kind of made a few changes to streamline this a little bit. So we would definitely love feedback. So if you have time at the end of the session, please make sure that you fill out the survey, or if you can fill out the survey like later. That is really helpful for us when it comes to teaching in the future. So for anybody that's joined, make sure that you pop into the document that you were provided. I'm going to drop the link again. Get Unity turned on and up and running. And basically how this class is going to go, I'm going to hand it over to Danielle, and she's going to walk everybody through this tutorial. So you will be building your platformer during the session. We will take a break midway just because it's a lot. And we love questions. So if at any point in time you need us to stop, you need us to slow down, you need Danielle to go back and do something over again, or you just need to ask a question, throw it into chat, unmute yourself and ask. We are happy to take the time and walk through this. If we don't get through the entirety of this, we don't get through the entirety of this. It's more important that you guys get the opportunity to play in Unity and get to ask the questions that come up while we do this workshop in real time. So we want you to be able to ask questions as it comes up. I think that is all I have right now. So Danielle, you are good to go.
Alrighty. I will go ahead and start sharing Unity. Does everyone have open? Have they created a new project? Have they downloaded the asset? Just want to take a quick gauge of that. Like Carrie said, if you haven't done that yet, this would be the time to start doing that. And if you need me to go through any part of that step, please let me know. Okay. I see one yes. I'm going to assume people are then in the process of doing all of that. So to start, let me show you, once you have Unity opened up, you're going to see like an empty screen. When you have the assets, when you have the free platformer asset downloaded, it's going to be added to your assets, which is going to be in your Unity account. You can go ahead and go to Window, and then Package Manager right here. And then you're going to, if it's not already there, you're going to click this tab and you're going to go to My Assets. And then you're going to go ahead and find the free platformer tile set. So I have it right here. And then you're going to go ahead and hit Import. And when you hit Import, it's going to show you this page. And all of these are going to be highlighted. I already have it downloaded just in case. But it's going to show you all of these. You can leave all of these checked. That's fine. I checked off the scenes because I don't need the sample scene, but if you want to include that, that is also fine. And when you have all of that, you're going to go ahead and hit Import, and it's going to import it into your project. Okay. So again, that is Window Package Manager. It's going to open up this window. Going to go to Packages, My Assets. You're going to find that asset and you're going to import it. Okay. So before we fully dive in, I wanted to just take a moment and explain why I have chosen a platformer. Um, and the pretty simple answer is it's an easy game to start into. There are a lot of resources online for building out a 2D platformer or 3D platformer. We are choosing a 2D just to make it a little bit simpler. Having a whole other dimension does add some complexity, but we're just going to do a 2D platformer. It's going to be something that a lot of people are familiar with. Mario, for example, is pretty recognizable. So in general, 2D platformers are a good way to start into game development. The other cool thing about them is it's uh, pretty quick to have a functional game. And what I mean by that is uh, the core mechanics that you need for a platformer, right? You got a platform and you got a character that can jump. Now, when you set that up, you have a game. It might be a really simple game, but it is a game nonetheless. So that's sort of the goal of this tutorial is to have a very simple but workable game. And like Carrie said before, we may not get to everything. We're going to see how long it takes us. As always, like please ask questions. I would rather you guys understand why I'm doing things than necessarily just step through things. Um, but you will get the tutorial at the end of everything. So if we don't go through everything, you will still have that resource. Okay. So to start, we're going to go ahead and create our tile map. So we're going to go to our hierarchy here. We're going to right click, going to go to 2D object, and then we're going to go to tile map, and I'm going to choose rectangular. And this will bring up a grid. It will likely bring up the tile palette. If it does not, you can find this window by going to Window, 2D, Tile Palette. And we're going to be using that to essentially paint our level. I'm going to go back to my tile map and I'm going to name it Ground, because this is going to be used as the ground for my level. And from my tile palette, I can zoom in. And because I have imported an asset, it's going to automatically load in this palette. And I'm going to go ahead and I'm going to select a block that I like. I'm going to make sure the brush is clicked on. And then I'm going to go to my scene and I can just go ahead and paint. So I'm going to add all these blocks. Maybe I'll add a slightly different one for the edge. And I've got a floor for my level. Now, since I'm going to be using this as the ground, I'm I'm going to add, and I'm going to add a collider component. So I'm going to make sure my ground is selected, going to go to its inspector. I'm going to go to add component, and I'm going to physics 2D. I'm going to find, where is it? I'm gonna search for tile map collider. There it is. And I'm gonna add tile map collider 2D. Okay. So this will go ahead and add a collider to our ground. Now, let's go ahead and we're going to make our player character. So we're going to right click in the hierarchy. I'm going to go to 2D object. I'm going to go to sprites, and I'm just going to do a capsule. And I'm going to rename this as player. Now, if we hit play right now, it's gonna take a moment to load. But if we hit play right now, we're going to see that nothing is going to happen because right now we just have the visual of our player and we have our uh, our tiled ground below. Not very exciting. So we're going to go ahead and add some physics to our player to make it do something. So we're going to go make sure player is selected. We're going to go to add component and we're going to go to physics 2D and there's rigid body 2D. Okay, so we're going to add that in. And I'm just going to go ahead and leave this as the default. Now, rigid body 2D is a built-in component to Unity that essentially adds physics to whatever we've added to. There is a 3D version, which is just called rigid body. And it's important that you have the correct one depending on your project. So if you are ever in a scenario where you're like, I have a rigid body, but nothing's working, make sure that it is rigid body 2D if you are in a 2D game, and vice versa if you're in a 3D, because otherwise it's going to cause some issues. Okay. So if we run our game now, you notice something happens, but we don't collide with the ground. Instead, we just drop, and that is because we have gravity on our rigid body that's ruled by the gravity scale right here. But why is it that our collider on our ground didn't seem to collide with our player? And that's because you need a collider on both objects you want to collide. If you have something that doesn't have a collider, it's not going to collide with anything. Makes sense. But it's, again, something that you might encounter as a simple mistake in your own classes where someone's going to be like, this isn't colliding. Well, did you make sure that both things have a collider and they're interacting? That's a good first step. So let's go ahead and add a collider to our player to make sure it can collide. So we're going to go to add component again, physics 2D. I'm going to do capsule collider 2D. Okay, and that's going to add it automatically. I'm going to go to my game view and I'm going to quickly change this to play focused. And what that will do is it'll bring me to the game view automatically. If you noticed before, it stayed in the scene view when I hit play. Now, because I have it to focus, it's going to bring up the game view. And you'll see everything's colliding now. which is great. Okay. Now, you may notice my player did fall over. So I'm gonna go ahead and I'm going to go to my rigid body 2D, and I'm gonna go to this constraints right here, and I'm gonna say freeze rotation. So I'm gonna check that off, and it's only going to affect the Z-axis. And all that's saying is, regardless of what the physics are for this capsule, don't let it rotate on the Z-axis. And that will help prevent it from falling over when I move it. Depending on the type of game you're making, you may want it to rotate. Maybe you have a ball that's rolling down or something. But for right now, I'm just going to let my player capsule be kind of rigid, so I don't have it flopping around. Okay. Gonna let people catch up for a moment and check the chat.
Yeah, and do let us know at any point if you need us to slow down.
So, oh, yes, Carrie?
And if you're just joining, we are at around step 9 is where we are at the moment.
Yes. So we are now going to dive into scripting. So as part of the install instructions that we hope that hopefully everyone has received, you will need a scripting editor. I am going to be using Microsoft Visual Studio. That is something that you can download along with Unity, but you can feel free to choose whatever scripting editor you feel comfortable with, provided it is um, able to work with you. So let's go ahead and select our player, and we're going to add our movement script. So my player is selected. I'm going to go to my project tab. I'm going to add a folder, and that's by right-clicking, going to create, and then folder. I'm going to call this scripts, and this is just for organizational purposes. And I'm going to go into my script folder, and I'm going to right-click, and I'm going to go to create, and I'm going to go to C# script. And I am going to name it player controller. Okay. And then I'm going to go to my player, let it load for a moment. And I'm going to take my player controller and I'm going to drag it on. So now that is a component of my player. A quick note about naming scripts. Once you name it the first time, it is very difficult to change it. And the reason is because Unity compiles those scripts, and it is directly through a file system. So if you rename it, Unity will throw an error saying, I don't know where the script is because I had it marked as this other name, and now I'm confused. So please make sure you have everything spelled correctly. If it doesn't say player controller right now, it's an empty script. You can go ahead and delete it and try again. But renaming can be a bit of a pain for scripts. Okay. So now we're going to open it up in our editor. So I am going to double click on it. And I believe I will need to reshare my screen because I think it's just on Unity.
Yeah, we just got Unity.
Okay, yeah, let me share my whole screen then. Can everyone see Visual Studio right now?
Yep.
Okay, awesome. Okay, so this is what you're going to see when you create a new script. It's going to have public class and then the name of your script, and then it's going to include mono behavior. For right now, you can go ahead and leave all of that as is. Mono behavior is one very large script that Unity will often use. So every script kind of inherits from it, unless you specifically delete that. But we are going to use some functions from mono behavior, such as the start and update. So we want to leave this here. Um, and yeah, let's go ahead and start scripting. So the start function, as you see here, Unity does include what is called a comment as to what start does. So basically, this function is called at the start of the scene when you first load it in and before the first frame update. So is everyone familiar when I say like frames for a game? Everyone gonna knows? Okay. So update is called once per frame. So that something is constant. That's something update is used for when you're constantly evaluating something. It can be a little expensive depending on what you have in there. So it may use up a lot of resources depending on your game. So you do want to be kind of careful what you include in update, because again, it's being called every single frame. We will be using both of these, so you can go ahead and leave these there. You do not need to delete anything. And right now, we're going to consider what we want the script to do. So something that I like to do is make a comment on what my script is going to be about. So I'm going to do that by doing 3 backslashes, and that's going to automatically fill in this sort of summary header. And I'm going to write for myself, this script manages the player character and how it moves and interacts with other objects. Okay, so that's just a note I'm leaving for myself and for anyone else reading the script so that, you know, play controller is a pretty general name. If I wanted to open the script, I could be like, oh, okay, this is the script that manages the player character and how it moves and interacts. Got it. Comments are really useful for explaining something that may or may not be obvious depending on your code reading level. So if this script is about how the player moves and how it interacts with objects, we have to think through how is our player going to move? What are the things that we want to keep in mind in actually getting it to do movement? Well, we know we have a rigid body, right? We added a rigid body 2D because we wanted the player to experience physics. Well, fortunately, we can use physics for movement. So we're going to go ahead and use the rigid body for our player for movement. The other thing we want to know in relation to its movement is how fast it's going to go, right? That's something that is a variable we are going to need in order to determine how our player moves. So we're going to write out public float speed. and I'm going to say equals 5f. And speed is pretty self-explanatory, but I'm going to write a comment anyway. And I'm going to say player's speed initialized, if I can spell, to 5, but accessible in the inspector if needing to be changed. Okay. Public is a way to mark a variable or a function as fully available. It's going to, and we'll see this later, it's going to show up in the inspector and allow you to change it in the inspector. It's also going to be able to be accessed by other scripts, both scripts that are completely separate from the script and scripts that inherit from the script. So public is a general access access token. Private is a different access modifier. Instead of being available in the inspector, instead of being available to other scripts, private means it's only going to be accessible within the script it is written in. And we're going to do private rigid body 2D. We're going to call this body. I'm going to make a comment. Oh, not that kind of comment. I'm going to make a comment that says references the player's rigid body 2D component to perform physics calculations. Okay. And I'm going to go down to the start function and I'm going to say body equals get component rigid body 2D. And depending on your scripting editor, it might suggest things that it thinks you needs, like it did just there. So when that happens, you can hit tab and it'll fill out for you, which can be useful. And I'm going to write a comment at the start of the scene. Let's grab our rigid body before we use it in script. Okay. Help if I could spell things. And again, these comments are just there just to make it a little easier to figure out what we're writing. Okay.
It's usually me with the spelling issues.
And I'm going to add one other thing before we move on, and that is I'm going to go to the top and I'm going to go above public class. I'm going to say require component. I'm going to say type of rigid body 2D. Okay. So this was something that I actually have added to this tutorial that wasn't in there before, but we have two variables here. We have one that is public, and we're going to show in just a moment how this can be accessed in the inspector. And then we have one that is private, which again is only limited within the script we are writing it in. And we have this set at the start to a component on the game object that we attach the script in, right? So get component is going to get the component specified from the game object wherever the script is attached to. Now, if the script is attached to a game object that doesn't have this component, it's going to throw an error. There's a couple ways we can mitigate this. One way we'll be showing later, which is try get component, which is a safer way where Unity will try to get the component, but if it's not there, it'll just return a false value, and you can write a script managing that. We'll demo that a little later. The other way we can avoid any potential errors and make sure the game object we're attached to has a rigid body or whatever component we need is to put require component at the top here. And what this will do is it will automatically add the component specified to our game object when we run the game. And if it is already on there, it will prevent that component from being removed. So this is a great way to make sure that this doesn't throw any errors, and to make sure whatever you have that really needs this component actually has it. So this was a useful thing I thought would be helpful to add. Okay. So I just want to show real quick, because I keep talking about it, if my mouse will cooperate with me. There it goes. What it looks like in the inspector for speed once it finishes compiling. So I'm going to go to our player, and you'll see right here, this is what I mean. So speed is accessible in our inspector, and I can change this value later. By setting it to 5 in the script, it's going to default to 5 here. If we do not specify any number, it's going to set to 0. Okay. So now I keep having to move the pictures around. So now we're going to get into the movement. So we're going to add another variable, say private float x movement. Sorry, x movement. Okay. And I don't think I've mentioned what a float is yet. But a float is a variable type that is for numbers that can be decimals. Another numerical variable type is an int, which would be an integer number, and that does not include decimals. And then there's also a double, which is a more specific decimal, to put it kind of simply. But for right now, we're just going to stick with floats because we will be using decimal points a little bit later. Okay. And we're going to go to our update function. And we're going to say equals input dot get axis horizontal. If I could spell that correctly. Horizontal times speed.
You're not supposed to let me rub off on you like this, Danielle.
It's hard when there's an audience. You just start forgetting how to
Just typing anything?
type. Yeah. Yeah. Okay. So what we just wrote here, we are setting our variable x movement to input get axis multiplied by our speed. What is our input get axis? Well, that is a built-in function that Unity has to get input from our keyboard. So input get axis specifically gets the input from our left and right arrow keys, as well as our A and D keys, WASD and the arrow keys. That is something that is specified in the settings of Unity. You can change it out, but since those are the most common sort of input for movement, I would just leave them. So we're going to get essentially like, are we getting any input from the right key? And if so, multiply that movement by speed. So move this amount of whatever our speed unit is by going to the right or going to the left. And we are putting it in our update function because we do not know when our player is going to hit whatever key, right? We have to essentially constantly check, hey, are you hitting the right key? Hey, are you hitting the right key? Hey, are you hitting the left key? Because we can't foresee that, right? So update is really good for input because it's something that we can't already know, and because that's something we're going to have to constantly check. Are we receiving input? Okay, yes, we are. Let's do this. Right? Now I am going to start on another function, and that is going to be, going to do void fixed update. And fixed update is something that Unity has as well, and it's a little bit different from update. You can actually see as I hover over here, Unity does have a definition for it. It says this function is called every fixed frame rate frame. So what does that mean and how does it differ from update? Well, we know update is called every frame. Fixed update specifies a fixed frame rate. And what that essentially means is it's the frame rate that is dependent on the physics that is in your game. So fixed update takes the time to perform physics calculations between each frame. So while update is sort of this constant, here we go, here we go, here we go, fixed update is going to say, okay, we have to calculate this. All right, that's done. Let's go to the next one. And it does that constantly like update, but the actual frame rate is going to differ. It's going to differ based on your machine. It's going to differ based on how much calculation you're doing in your game, and stuff like that. So it's going to be different for everybody. And we are going to use it for physics calculations because of that, because we cannot guarantee that every device is going to calculate things at the same rate. And a quick note, if I'm going too fast or you're still not clear about everything, there are links in the tutorial. So if you go through everything and you're like, well, actually, what does fixed update mean again? There is a link to Unity's manual page in the tutorial, so you can check what their own definition is as well. So in fixed update, I'm actually really quick going to write a comment here just so that I can remember. I say fixed update is called every fixed frame rate. Use this for physics. This for case calculations. I'm going to write in here if X movement does not equal 0, So if we have layer input, so when we get input from our right or left keys, that is going to return a value. If you are hitting the right key, it's going to return a 1. And if you're hitting the left key, it's going to turn a -1. So if our X movement here is 0, that means that there is no input, because that get axis would just be returning 0. And then we're going to write move layer. And this is all red right now because we haven't defined this yet. So I'm going to go ahead and do private void move layer. And that's going to fix that little red error right there. And I'm going to write body dot velocity equals new vector2 x movement body dot velocity dot y. And essentially what this is doing, I am setting the player's velocity based on their input and speed, which is our X movement. We are not directly changing the Y value. So we're changing the X value based on a horizontal axis. We are not directly changing the Y value, so we're keeping it to whatever it is currently set to, because that's going to be adjusted based on gravity and later on jumping. Okay, so we're going to hit save. Just going to make sure I have everything I need. All right. Does everyone have this written down? Just take a moment to pause and make sure everyone has everything. Okay, I will take that as a yes. So now we're going to go ahead and test our script. I'm going to hit play. And my player is moving. Awesome. So go ahead and run play yourself and make sure that your player character can move left and right. And it should be able to move on the arrow keys and WASD. Now, you may notice as you move it around, there might be some jittering as it goes along the ground. If you do see that, one way to fix this is to go to your ground. And we're going to go to Add Component. And I'm just going to type in Composite Collider 2D. I'm going to add that. And you'll notice that this automatically adds a rigid body 2D. I don't want my ground to be moving. So I'm gonna change the body type of my grounds rigid body 2D from dynamic to static. So what this is going to do is it's still going to experience physics, and I need it to experience physics because of my composite collider, but I don't want it to move around, so I'm going to leave it as a static uh, uh, physics component. So we have this composite collider. We're going to go to our tile map collider, and we're going to say used by composite. I'm going to check that off. Okay. And all this is doing is the composite collider is telling us to treat this as one big collider. So before this was added, it was treating each individual tile as its own collider. This just meshes it together. So that will help get rid of any jittering that will occur from the slight like bumps between the colliders. Okay. All right. So I'm going to hit save on that. And then I'm going to go back to my player controller script. And we're going to start adding jumping to our script. So I'm going to go into here. I'm going to add in, oh,
We had a capsule fall over.
we had a capsule fall over. Okay. So what you can do if that happens is you can go to your player. You can go to its rigid body 2D. You can go to constraints, and you can do freeze rotation on the z-axis. And that will stop it from rotating on the z-axis, and that should prevent it from falling over. Okay. So getting into jumping, I'm going to take a moment and think, what do I need to determine for it something to jump? So I want to know how much force, how strong of a jump my player can do. And I probably will want to be able to change that, as I test things out. So I'm going to add a public float jump force. Okay. Right. And then I'm also going to think, well, how do I want to tell the Unity, like, when should I jump? And that's probably going to be on input. So what I'm going to do is I'm going to go under here and I'm going to write private bool call jump was false. And a bool value is just a true or false value. And then I'm going to go to my update function. Remember, update is called a once per frame, and we use it to get input because we don't know exactly when people are going to provide the input. So we have to constantly ask for it. I'm going to say if input dot get button down jump. I'm going to say call jump equals true. So similar to get access, this is telling me when I receive a notification that the jump button has been pressed, we're going to call jump. You notice that I literally said the jump button. Because jump is such a common thing in games, this is another thing that Unity has a default for. The jump button will, by default, translate to the space bar on your keyboard. Again, that is something that you can change in Unity's defaults, and I can show you where you would change that in a little bit. But for right now, we're going to have jump, and that's going to mean spacebar. So we're going to say when our spacebar is pressed, call jump is going to set to true. And then I'm going to go ahead, I'm going to go down here, and I'm going to do private void jump. And I'm going to say call jump equals false. Body dot add force transform dot up times jump force mode 2D dot impulse. Okay. So why do we have this call jump here if we're setting to true and setting it to false? Well, essentially, we're going to use it to bridge our input to our physics calculation. So we hit the spacebar. Okay, we have called jump. We set it to false when we actually do the jump so that we can let them know, hey, we've received the call. We're good. We can use that again later. And then the body.add force is a physics function. The transform.up is the y axis. So we're going to add a force equal to our jump force to the player capsule that will send it along the up axis. So it's going to say jump this high and go up. Force mode 2D.impulse is a type of force that just means that it's going to happen immediately and just at once. Okay. So I said earlier, we're going to use call jump to bridge our input to our physics. We're going to do that in our fixed update. So we're going to say if call jump, jump. So why did we include this call jump? Why not just put jump like right in here when we get the get button down for jump? Well, remember, we're using physics to jump. So we need to let Unity run physics in the fixed update because it's going to need the time it needs to calculate, right? So we're going to tell Unity, hey, I have received input. The player wants to jump. When you are next available in your fixed update, please perform a jump calculation. We have that available. Let's go ahead and jump. So we do not need this call anymore. We want to turn it to false so that when we next receive a spacebar press, we're going to say, oh, okay, we jump again, right? Does that make sense?
You got head nods, so I think people are
Okay.
following along.
All right. So you notice we didn't set any number here to jump force. So when we go back to Unity, it's going to compile. Gonna go to our player, and you notice our jump force is set to 0. So we're gonna go ahead and, I don't know, we'll just say 10 for now. But this is another important thing to keep in mind. If you have a student who adds a jump variable and they go to play and they're like, I'm not jumping, ask them, did you set a number to your jump force? Because they might just go ahead and write their variable, not initialize it to anything, and then forget to add something in the inspector. All right, so let's go ahead and test out our character. And we are jumping. So take a moment, go ahead and run play, and jump. And let me know if anyone finds something that seems a little off or isn't working right.
If you keep pressing jump, it just goes higher and higher and higher and higher.
It sure does. So we have infinite jumping. And the reason for that is we've only said, hey, jump when you hit the spacebar, right? There's no other condition that says, okay, you can only jump in this, certain manner. So now we're going to go ahead and add that condition. Now, jumping infinitely might actually be something you want, but for this game, we're gonna go ahead and add something that prevents it from jumping
I know,
in the air.
I know a project we could add infinite jumps to, but no.
So, how do we want to tell our player it's okay to jump? Well, there's several different ways we can do this, but one approach is we're only gonna jump when we're on something that is jumpable. So how I'm gonna do that is I'm going to create a layer, and I'm going to assign certain objects to that layer. And then in my script, I'm going to say, hey, if we're touching something on that layer, you can go ahead and jump. Um, okay, just want to check so I'm going to go to my ground, and I'm going to go up here, and I'm going to see it says layer, and that's set to the default. I'm going to go ahead and add a layer. And I'm going to call this layer surface. And layers are really useful in Unity. They can be used as we're going to do, which is for collisions, and they can also be used for rendering. So you can specify certain things on different layers and render them differently. But we're just going to use them to organize collisions for right now. So you've added a layer. You do have to click back on the game object and go specify to what layer it is. It doesn't add it when you add the layer. So I'm going to set that to surface right there. Okay. And now going back into our script, into our player controller, we're going to create a new variable. It's going to be public layer mask surface layer. Okay. And I'm going to go ahead and scroll down, and I'm going to write private bool is on surface. So taking a moment, all of our other functions have used void, but now we are using bool. So essentially, void means it returns nothing. So a function, when it's called, it can return a value if you specify it. Void returns nothing. By specifying bool here instead of void, I'm saying I want this function to return a bool value. So you notice right now it's giving me that red squiggle because it's angry that I don't have a return path. Well, I'm gonna give it a return path in just a moment. We're going to say vector2 position equals new transform dot position x transform position dot y minus transform dot local scale dot y. Float, and I have to move portraits here. Float distance equals 0.2f. And then return physics 2D dot overlap circle position distance surface layer. Okay. That's a lot of words. It is okay if you don't understand everything right now. Essentially what I am doing is I have this position which is going to be in the middle of our player character. So it's going to be where its transform X position is. So transform refers to its physical position in the space. So we're getting its X position. We're getting its Y position minus transform.localscale.y. So what does this mean right here? Well, essentially, the local scale is how big it is. By the y value, it's essentially how tall it is going along the y-axis. So we're getting the y position of our player character, subtracting it by how tall it is in order to get its position essentially at its foot level. So right at the bottom of our capsule. And then the float distance here is basically the size we are setting to our circle. So we have this physics2d.overlap circle. And what that is essentially doing is it's adding a collider specified at our position with a radius set to our distance. And it's specifically set to only collide with things in our surface layer. So that's why we put our ground to our surface layer. And we can add other things to our surface layer as well. And this way, our player will only be able to jump on things in our surface layer. So where are we going to call is on surface. Well, we're going to say we want to only be able to jump when this condition is being met, correct? So we're going to put it with our jump conditional, right? When our spacebar is pressed. So we're going to say is on surface and that's how you add an and for a condition, and input get down is jump. So if we are on a game object that is in our surface layer and we are hitting the spacebar, we can now jump. Okay. I am actually going to add one more line of code here. You do not need to have this, but I'm going to do it so that we can visualize things a little bit better. I'm going to do debug.draw ray position vector2 dot down times distance, and sure, we'll do color yellow. So the debug function helps me for debugging, as you might have guessed. But essentially, in our Unity scene, it's going to draw a ray at our position, going down the length of our distance, and it's just set to the color yellow. You can change it. Actually, I'm going to change it to magenta because that's a little easier to read in the actual Unity scene. So I will show you what that actually looks like in just a moment. But we're going to go ahead and save. Just going to take a moment to pause to make sure everybody has this in.
We also probably got to check and see if anybody needs a break. So if anybody needs like a 5-minute
Yes.
break, we can also take one since we are a little bit past the halfway mark.
Here how about we take a break right after we test this? That'll be a good break point. So I'm going to go back to our Unity scene, and I'm going to hit play. I'm going to quickly go to my scene, and you can see that's my little magenta line. And if I hit space, nothing is happening. So that means there is an error. So let's figure out what that error is. And that error is that I forgot to assign my surface layer. See, even I do this. After years of developing Unity, I will also forget to assign things in the inspector. So I'm going to go ahead and set our surface layer to be surface. Definitely intentional that I missed that. So now our surface layer is surface, and let's go ahead and run Unity and see if it works. Hooray! And if I rapidly hit the spacebar, I am only jumping when I touch the ground, which is what I wanted. Is everyone else also getting that? Make sure you assign the surface to the surface layer. All right, I see some head nods. Okay. All right. Do you want to take a 5-minute break now?
Does everybody need a break, or we usually offer because it's nice? Yeah, we got the thumbs up. So let's take a 5-minute break.
Okay.
We will be back in 5 minutes. We'll probably still be here, but if anybody has questions, feel free to ask them. Get up, stretch, grab water.
Okay. I think
We should be back.
we
So
should be back.
Yeah.
So I'm gonna go ahead and continue. Like I said, we are on step 16. So we are now going to populate our level a little bit so we actually have things to jump on. So I'm gonna go to my grid right here. I'm gonna right click. I'm gonna go to 2D object again. I'm gonna make another tile map, and I'm just gonna make it rectangular again because my tile map is square, uses squares. And I'm gonna call this platforms. I'm gonna make sure it is set to surface layer. I am going to add in the tile map collider. I am going to add in the composite collider, like we did with our ground. I'm gonna also set our rigid body 2D to static like our ground for the same reasons. And I'm gonna add one more thing to distinguish the platforms from the ground, and that is our platform effector. So I'm just gonna go ahead and type it in, and that is platform effector 2D. And tile map collider, I'm gonna say used by effector and used by composite. So the platform blah 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 blah. The platform effector. Let me first actually get a platform on here. Let me make sure my tile map is set to platforms here. I'm gonna just gonna paint a quick platform here. And just to make sure that is in the platforms, yes, that is. So I have a little platform here. So the platform effector lets you do that thing if you've seen platformers where you jump through it from the bottom. So just quickly to demonstrate that. Um, Let me actually set it to. I have to check. Oh, sorry. I need to set my composite collider to use by effector. That's what I was missing. There we go. Let's make sure that works now. Yes, there we go. So that's the difference now between the ground and the platform is I can do that little jump through, which I just like to have for the platforms. But again, if you're like me and you just ran ahead to play and it's not letting you go through, make sure use one way is checked, and then make sure composite collider is used by effector is checked, and then tile map collider used by composite is checked. Okay. So we've got some platforms, we've got some jumping around. The next thing we're gonna do is we're gonna add some hazards. So I am gonna go ahead and drag in some hazards. So I'm gonna go to my project tab. I'm gonna go to my platformer tile set. I'm gonna go to props, and there is a hazards folder right here. And let me just drag in some good old spikes. Name this if I wanted. I'm just gonna keep it hazards for right now. And right now this is just a sprite of the hazards. Another way you could do this is you could go to your hierarchy, you could go to 2D object, sprite, and you can just add in a square, and then you can change it from there in the sprite renderer to the sprite you want, or just drag it in, whichever works for you. I'm just gonna go ahead and delete that square for now because I already have my hazards right here. So we have our hazards. I'm gonna go ahead and add a collider to it. So I'm gonna go to Physics 2D, and I'm just gonna add a box collider. And if I go to Edit Collider right here, I can see, what the collider is, and I can make changes to it. Unity is pretty good at setting it to the right size. I am not particularly worried about, all this space in here, because the way my character is shaped, the overlap is going to be fine. But there are options to adjust the collider if you are wanting it to be more particular. And then we have these hazards, and we're going to have the player take damage from our hazards, right? So in order to relay that we are taking damage to the player, we're going to add a health bar. So I'm going to go to my hierarchy. I'm going to right click, and I'm going to go down to UI, and I'm going to go to slider. And notice this kind of just appears really big, right? But if we actually go to our game view, it's actually pretty small. So that is the difference between the actual scene of the main camera, right? This is our main camera. This is the viewpoint. And then this is our canvas. And this is where all of our UI are gonna go. Now, the UI can, you can adjust the display here with the canvas. So we can, right now it's meant to overlay over the entire screen. We can adjust this if we would like to. I am going to just leave it like this for now. But you do have other options. You could set it to fill in to the camera specifically, if that makes it a little bit easier. The canvas is over here, and now our slider is here. You can also, we'll actually show this a little bit later, but you can also put it in the world space as well. If you have this warning, you can just go ahead and click this to get rid of that. This is a pretty simple game, so you don't really need to worry about that. And you notice it did add an event system automatically. And the reason it did that is because this is needed to detect UI input. So we have a slider right here, which is by default interactable. So if we go and hit play right now, we can move this slider around. And we need the event system in order to detect that input and help Unity know what we're doing with the UI. So you can go ahead and just leave that for now. I'm going to move this around a little bit. I actually do not want my slider to be interactable because I want to turn it into a health bar. So I'm going to do a couple things. I'm going to make sure it's selected. I'm going to change it to say health bar. I'm going to set it to not be interactable by checking this off right here. I'm going to set its transition to none. Because I am not going to be utilizing the handle. And in fact, I'm gonna go ahead and set the handle rect to none. And I'm gonna go ahead and just delete this entire handle slide area. I don't need it. Okay. I'm going to adjust my fill so it fills the entire way. Another way you can do that is just by setting these to 0. So that's going to stretch out for the entire fill area. And I'm gonna set my fill to also fill this. Oh, not like that. I'm going to reset this, I think. And then adjust. Actually going to. There we go. So what I just did is I set I went to the anchor presets. I held down Alt and I set it to fill completely. Down Alt, it'll automatically fill it in that way. And that way it just fills in the entire rect right there. And I'm just gonna change the color to red. I can adjust the value here and see how that will look. Okay. So I'm gonna check my game. I can make this maybe like a little bit bigger, just so it's a little bit noticeable. But again, that's kind of customization. You can play around with that if you would like. And once everyone has their health bar, we're gonna go back to our scripts. Gonna go back to player controller. And And I'm going to add a reference to that health bar. So I'll do public slider. And by adding that, it also adds Unity engine.ui. This is needed if you are referencing any UI objects in a script. So it's giving you an error right now. Make sure you have this at your top. And I'm going to say health bar. Okay. And I'm going to add public int max health. If you recall, int variables are non-decimal point variables. I'm going to do private int current health. So in my inspector, I'm going to set a max health. And in my start, I'm going to say health bar. Remember, this is my slider. Max value equals max health. So at the start of the scene, whatever I have set to max health is going to then change the slider. It's going to set its max variable to be that max health. Going to say current health is the max health. So we're going to start at full health. And our health bar dot value is going to be our current health. Okay. And let's add a way to change the health. So we're going to add a damage function. And I'm going to say public void damage layer. Say int damage. Current health minus equals damage. And this is the same as writing current health equals current health minus damage. This is just shorthand for writing that. Health bar dot value equals current health. And if current health is less than or equal to 0, we're just going to restart the scene if the player reaches 0 or negative health. So I'm going to do that in one line. Just going to say scene manager. And you're going to need to add Unity engine.scene management to be able to use this. Load scene manager dot get active scene dot name. Okay. So restart the scene if player's health reaches. Okay. So we set up our health. We have a reference to our health bar. At the start of the scene, we're going to set everything to max health. In our damage function, we're going to take in what's called a parameter. So whenever and wherever damage player is called, we also have to pass through a value, which is going to be the damage our player is going to take. We're going to subtract from our current health whatever that damage is. We're going to set our health bar to reflect that current health. And if that current health is 0 or below, we restart the scene. So we have our player death, quote unquote. The reason why I specify less than or equal to 0 is because I cannot guarantee that the damage will always subtract into an even amount that equals 0, right? We might take a lot more damage than we have health left. And so if we just set this to 0, we could essentially have negative health and keep playing. So we want to make sure if it's less than 0 to count that as a death. And then we also made this public. So as you may recall, public means that it can be accessed by other scripts. And the reason why we have this as public is because that's exactly what we're going to be doing. We're not going to have the player damage itself, right? So we need another script to call this function at an appropriate time. So let's go ahead and do that. I'm going to save. Going to go back to Unity. Let that compile for a moment. I'm going to right click and I'm going to go to create. I'm going to go to C# script. And I'm going to say this is hazard behavior. Okay. And I am going to let that compile. I'm going to go to my hazards and I'm going to go ahead and add this as a component. Okay. I'm going to go ahead and open up my hazard behavior script. And I am going to get rid of the start and update. I'm not going to need them. And I'm going to make a public int variable called damage. And I am going to think, when do I want to inflict damage on the player? Well, I want to inflict damage when the player collides with the hazard, right? So I'm going to go and add a private void on collision enter 2D. Make sure it's 2D because we are in a 2D game. And I'm going to let that fill in. It's going to take its own parameter, collision2d.collision. And this is another built-in Unity function. So at the start of a collision, so we have game objects that have colliders. They are colliding with each other. As a note, one of them, at least one, must include a rigid body to let this function execute. When they start colliding with each other, that is when this function occurs. So this is attached to the hazard script. The collision that I want to check for is if it's the player so that I can call it to get damage. So one way we're going to check to see if it is the player is we're going to check if it has the player tag. So I'm going to write if collision dot collider. So if the collider in our collision dot compare tag is player, and we'll add that tag to player in just a second. If that tag is player, I'm going to say, I'm going to put another if statement. If collision dot game object dot try get component out player controller player controller player controller dot damage player damage. So we have a collision. Does our collider have the player tag? Yes? Okay. I am now going to attempt to get a component from that player collider in order to call a function using that component. So I'm going to say, does it have the component player controller? If so, give me that reference. I'm going to use it to call damage player, and I'm going to pass in my damage variable. Now, if this game object does not have the player controller component, that is okay. It will return false and it will not try to execute this code. If we had just said get component and that didn't have the component, it would have returned an error. Okay, so this is the other way you can avoid that error with get component. Everybody got that? Everybody understand that? Okay. So I'm going to go back to Unity. And I have a few things that I need to check. I need to assign a damage. I'm going to set that to 2. Just a random number for now. I need to go to my player. I need to add a tag. And Unity does have by default a player tag, so I'm going to go ahead and select it for my player. And then I'm going to assign my health bar as a reference. So that's my slider. And I need to add a number to my max health. So I'm just going to put 10, whatever. Okay. So I've assigned a max health. I've assigned my health bar. I've assigned the player tag. And I've assigned damage. So let's run it and make sure it works. Okay, so I can move around. And I am taking damage every time I bump into this hazard. And when I reach 0, I restart the scene. Is everyone getting that? Again, I'm bumping into the hazard. It's taking damage. When I reach low enough health, I restart. All good? So we are running a bit low on time. So I am going to give you guys a choice. Would you like me to show how to add a pushback when I run into the collision, or would you like me to show another way to interact with objects in the scene where we push a crate onto a button and it turns something else off?
My cat arrived. Sorry.
Like to see the action.
Which one?
Watching, like, press a button, something else happens.
Press the button? Okay. So we're going to go ahead and just skip the pushback for now. Again, that is all included in the tutorial, so you can go and see that in later. But we're going to add, we're going to go to step 27. And I am just going to very quickly add some things to my level. I'm going to move my platform a little bit. I'm going to add another sort of platform. Okay, and I'm going to go to grid, and I'm just going to very quickly make a wall tile map. So I'm going to go to rectangular. I'm going to call this walls. I'm just going to add tile map collider. Okay, and I'm just going to fill in a couple walls here. And I'll show why I'm doing that in just a moment. But that is just so that I have something to stop things for. So I'm just gonna move this guy over here. And I'm gonna go to my props. I'm gonna go to actionables and I'm gonna add in a button. And I'm gonna add in a crate. Okay. So I am going to add a box collider to this crate. Box collider 2D. And I'm going to add a rigid body 2D. And I am going to change the mass to 10. I'll show you why I'm doing that in just a moment. I'm going to go to my button over here and I'm going to rename this button just so I can better recognize it. I'm going to add a box collider 2D to this. And I am going to add a script to my button. So I'm going to go to my assets, going to go to scripts, I'm going to right click, I'm going to go to create C# script. I'm going to say button behavior. Okay, I'm going to add it to my button. Open it up. I'm going to get rid of the start and update. And I am going to do another requirement. So I'm going to say require component type of sprite renderer. So I am going to change the sprite of the button when it is pressed. So I'm going to get a reference to a press sprite. Say public sprite press sprite. Say public float required mass. I'm just going to set that to 5 for right now. I'm going to do another private void on collision enter 2D. Oh, I did not do the 2D. Collision enter 2D. Collision D. Okay, that is all correct. Now I'm going to do if collision dot collider dot try get component out rigid body 2D collider body. Okay, so if our collision has a rigid body, if collider body dot mass is greater than or equal to required mass. So that's why we had the crate set, we set its mass as something else. We're going to get component sprite renderer. Sprite equals press sprite. So when something heavy enough essentially goes onto the button, we're going to mark it as pressed. Now, what else do we want to happen when this button is pressed? Well, we could specify something by typing it in here, or we can kind of let it be open-ended. And one way to do that is by adding an event. So what I'm going to do is I'm going to say public Unity event, and that's going to add Unity event engine.events on press. And I'm going to say when this condition is met, on press dot invoke. So what is our Unity event here? Well, if we save this and we go back into Unity and we compile, we see we have this empty function here. So we can set different things to happen when that on press occurs, which is marked by when we say on press.invoke. So I'm going to go ahead and I'm going to hit the add button and I'm going to drag in my hazards. And I'm going to say my function, game object, set active bool, and I'm going to leave this unchecked. And what that will do is when my button is pressed, and the mass is of the button, when on press conditions are met and it is called, we're going to set the hazard to inactive. So I'm gonna move crate over a little bit, and then I'm going to hit play. I'm gonna go over to my crate and I'm gonna drag it over. And I forgot something. I forgot my button's sprite here.
Forgot your press
Let me
button.
check. I forgot my press button. That's why it disappeared. So let's try that again. Gonna go over here. Go over here, and we're gonna drag it over. And there we go. So my crate's on my button, and it turned off my hazards. Now, I'm gonna set my button to surface, and I'm gonna set my crate to surface so that I can jump off of it. And that the reason I'm doing that is because I'm gonna show you what happens when the player jumps on the button. Nothing. Because I do not have enough mass to press that button. Okay? Does that all make sense?
We got some nods. We are in our last 6 minutes.
We are in our last 6 minutes. Yes.
So do you want to walk people through what's kind of left in the tutorial? Because obviously we didn't have time for everything, but the document
Yeah.
we gave you has a ton of stuff. So there are other features that you can add to your project using the document.
Yes. So what's left? We do have it does show you how to add pushback, as I mentioned before. The other thing that it will let you do is essentially you can add in a chest, and you can collect a key. And when you have that key and you go to the chest and hit a button, it'll open up the chest with that. I don't think we have enough time to show all of that. We would probably only get a
Yeah.
little bit in there. But it does use a slightly different collider. It uses a trigger collider, which the regular collider is just you run into it, it stops you. A trigger lets you pass through it. So you would use a trigger if you wanted to go like in front of something, but still react to that collision. And it also shows how to set up UI text that appears like in the game world. And that is with that world space that I mentioned before.
So ultimately our intention was to give people the tools to be able to make a super basic platformer. They are honestly one of the kind of most popular things that we see for student builds or initial student builds. So this document should help you, one, set something up and then be able to kind of utilize these components to make something bigger or grander, because it'll give you a foundation for how a lot of the stuff is done.
Exactly.
Does anybody have any questions before we exit? You don't have to have questions by any means. It is end of day on a Wednesday. Okay. I just want to say thank you to everybody for joining us. I hope that this was helpful or educational and informative in some way or another. Again, there's a link to the survey at the top of the document. Please take a second and fill it out. You can take a second now or later. And again, it helps Danielle and I know how to adjust these things in the future. We know that Unity's a big, meaty platform. We know that this class kind of runs you through a lot. And, you know, we love the feedback because it lets us know what we need to change or adjust, if there's things that would be more helpful in the future. All of that feedback is really something that we appreciate. We read it, we talk about it, and we make adjustments for how we use this material moving forward. So if you do not have questions, you are good to roam free, have a tasty meal, and I hope everybody has a great rest of your day.